September 1st, 1859. The astronomer Richard Carrington is performing his daily measurements of sunspots, dark regions that regularly appear on the surface of our sun. All of a sudden, he's blinded by a flash of light so intense he thinks his equipment must be broken. But soon after realizing that everything was intact, he just stared in awe, unaware that he was witnessing the first omen of the strongest geomagnetic storm recorded in history. By the following day, the storm would wreak havoc upon global communications. And that storm would soon bear his name. Richard Carrington was born in 1826 from Richard Carrington and Esther Clark Aplin. He displayed a love of astronomy since a tender age, and due to the fact that his father owned a major brewery just outside of London, he had the means to attend Trinity College once he turned 18. Now, his father initially wanted him to be a man of the clergy, to follow the path of the church. But Richard never truly forgot about his love for the cosmos, and inspired by the atmosphere he could breathe in the halls of Trinity College and by lectures on astronomy by a certain Professor James Chalice, Richard defied his very creative father, Richard, and said, "F you, I'ma do my own thing." And that's how he started a career in astronomy. Soon after graduating, Carrington found employment at the University of Durham, I don't know. But he quit after a few short years, unsatisfied with the research opportunities that were provided to him, and even more upset at the inadequacy of the tools that were present in the university's observatory. You see, Richard had been toying with an idea for a while. Inspired by his colleagues and peers, he decided he wanted to make a catalog of all the stars surrounding the North Pole up to the 10th magnitude. To explain what that means, I just have to tell you that stars of the 7th magnitude are the faintest stars you can see with your naked eyes. And to do that, you need to be in the middle of the countryside, far away from any light pollution, without a full moon in the sky. Now, stars of the 10th magnitude are about 16 times dimmer than that. And Riccardo Carrington wanted to catalog every single one of them. This Sisyphean endeavor would later prove to be a tremendous achievement, earning him the highest recognition from the Royal Astronomical Society, the RAS Gold Medal. But future generations would remember him for something much more impactful than his star catalog. Without fentanyl, you can only really see stars at night. So while he spent his nights classifying stars, Richard decided to spend his days staring at the sun. He set an apparently simple initial goal: measure how fast the sun rotates, if it does so at all. The first mention of a sunspot is found in an ancient Chinese divination text from 800 BC. It mentions a small obscuration detected on the surface of the sun. If you could travel to that time and go into a coma for 770 years, you'd wake up in 30 BC. And you'd still be in China, where you would find the earliest regular observations of sunspots in the form of imperial records from royal astronomers of the time. But to get the first meaningful discovery out of sunspot tracking, humanity had to wait until the arrival of Richard Big Dick Carrington and his purpose-built Red Hill Observatory. As he was thinking about his question on the sun's rotation, he had an idea. He could probably tell if the sun was rotating by merely checking to see if the sunspots moved across the sun. And if you had the same thoughts as Richard, congratulations, you are shit out of luck. The sun is an outrageously hot ball of plasma. You can picture plasma as a superheated gas that is also electrically charged because it's made of electrically charged particles like electrons or ions. But we don't have to get too much into that, okay? Just picture it as super hot electrically charged gas. Because that's what mattered to Richard Carrington. That is what allowed him to be the first man in recorded history to catch a glimpse of our sun's real nature. In a way similar to me stealing a peek of your sister's bosom. Short but intense. In his daily efforts of tracking the ever-changing locations of the sunspots, Carrington noticed something. Different clusters of sunspots seemed to move across the sun at different speeds, but they were not moving at random. Spots closer to the solar equator seemed to move faster than spots farther away from it. And to truly grasp the significance of this, we first need to properly answer the question, what is a sunspot? Like our own planet, the sun generates its own magnetic field. It's created by all of that electrified plasma swirling around. But while our own magnetic field is somewhat regular and stable, the sun's chaotic plasma is constantly tweaking the out, and sometimes turbulence arise as a consequence of this. These turbulences interfere with how the plasma on the surface mixes with the plasma inside the sun. And that's what sunspots are, points of reduced or disturbed motion. They can be about 1000 to 2000 degrees Celsius colder than the usual temperature on the sun's surface. In August 1859, Carrington could not have known that sunspots are only one of 3 symptoms of disturbances in the sun's magnetic field. They're the most apparent and they are the easiest to spot. Some are so big you can even see them with your naked eyes. But as for the other 2 symptoms, Carrington would soon experience one of the 2, and he would spend the rest of his soon-to-be tragic short life without ever even knowing about the devastating, hard-to-spot 3rd symptom. On the morning of September 1st, 1859, Carrington was carrying a ton of his usual work. He was particularly interested in a group of sunspots he had been following since August 28th. He had even carefully copied the shape of the cluster in his notes. At 11:18 Greenwich time, a sudden flash of lights almost blinds him. By his account, it was so incredibly bright that he initially believed his equipment was malfunctioning, that somehow a hole had been torn through one of the membranes he was using to safely observe the sun. He also recounts that by the 60 seconds or so that it took him to summon a witness to experience that marvelous thing alongside him, the flare had mostly withered away. And by 11:23, a mere 5 minutes after its initial appearance, the flare had vanished completely. He had just become the first known witness of a solar flare, a huge burst of electromagnetic radiation coming from the sun. Richard had correctly speculated that the flare must have occurred on the sun's atmosphere. This is because, despite its apparent violence and speed, it had left the underlying sunspots completely unchanged. Carrington estimated that, in those fleeting 5 minutes, the flare traveled about 35,000 kilometers across the surface of the sun. But something else had happened alongside the flare. What he observed was only one half of the phenomenon. Alongside the flare, completely invisible to the human eye, a gargantuan wave of plasma had been released and it was traveling towards Earth. We now call such phenomenons coronal mass ejections, and this particular one would take another 15 hours to reach our planet. In the early hours of September 2nd, an aurora brighter than any in recorded history shone over most of the world. Comparing the location of collected testimonies from the time with the usual location of aurora truly reveals how unusually far the aurora stretched. A fun little testimony from someone living in the eastern United States tells that it was possible to read a newspaper just by stepping outside and letting the bright red aurora illuminate the page. Another story is about a few gold miners up on the Rocky Mountains. They woke up and prepared breakfast because the sky had turned so bright that they believed it was sunrise. And there's many little tales, many little testimonies that help us paint a picture of this beautiful event. Among those stories, though, there are some peculiar ones. There is a very interesting exchange that happened between 2 telegraph operators communicating from Boston to Portland. It shows us a glimpse of the true power that was behind the Carrington event. In case it wasn't clear enough, these 2 telegraph operators were capable of communicating while both of their telegraph stations were completely unpowered, okay? Unplugged, disconnected from any power source. The geomagnetic storm caused massive turbulences in the Earth's magnetic field, and those turbulences induced a current inside of the telegraph's lines, which allowed them to talk without any external source of power over thousands of kilometers. But that story seems to be a bit more of an exception. In most cases, telegraph lines were rendered unusable, and that was kind of just it. Sure, there were some fires, and some parts of the telegraph network went down for weeks, but most of the world went business as usual by the following morning. So the Carrington event I was hyping up was a relatively tame event, all things considered. But that's only because there wasn't much in the way of electrical shit for the geomagnetic storm to destroy. Kind of like having a toddler throw a tantrum in a padded cell. The worst it could do is shit itself. But what would happen if something like that were to occur today? Let's say it is the metaphorical equivalent of bringing that tantrum-throwing little piece of shit into a room full of nice, delicate, brand new glassware. It would be extremely fun if I dropped all of this right now and shattered it into a quintillion pieces, but these are all the glasses I have, and then I would have to drink from my own two hands every single meal for the rest of my life. If you think that the worst that could happen is that some computers get burned out or that some areas of the world experience a 24-hour-long blackout, you disappoint me. By some estimates, there's a risk that some parts of the world could stay in the dark for years due to cascading failures in different parts of power grids all around the globe. High voltage transformers would be at the core of this issue. These are very sophisticated components that are present in every single power grid around the world. In our mostly functioning society, it takes weeks to have a high voltage transformer built from scratch. Now imagine how long it could take to replace a quarter of all the high voltage transformers located around the globe. And while many countries mandate by law the installation of protective equipment that would save the power grid in the case of geomagnetic storm, such equipment could not withstand something as powerful as the Carrington event. They would be essentially useless in such a scenario. Scientists estimate that global food production could drop by 38 to 48%. And in some parts of the world, like Central Europe, the reduction could be as high as 75%. It would be mostly due to problems with processing plants, maintaining farming equipment, and the inability to produce much needed fertilizers. We could even experience a global famine of an unspecified length. It could maybe last a few months, and we could go by with the food stocks we have. It could maybe last a year, and we might need to ration food, but maybe it takes 5 years to get fully back on our feet, and during that time, millions of people starve to death. It is genuinely that unpredictable, because we are talking about a poly-crisis, a crisis spanning several of the systems that make up modern society. With such high complexity, no one could ever possibly produce an accurate forecast. And this is not some merely hypothetical scenario, okay? It's not a matter of if it will happen, it's a matter of when will it hit us. In 2012 we had a close call. A huge coronal mass ejection missed us by 1 week. And by some estimates, if it had hit us, we would have experienced a Carrington class event. Now, I'm not saying all of this just to make you sad and depressed. It is actually entirely possible to prepare and shield all of the power grids around the globe against a Carrington class event. But due to how expensive it is and due to policy and the lack of legislation surrounding it, no one really does it. So one of the reasons for making this video is that we have this really huge problem that is kind of impossible to predict, and it could happen in your lifetime or maybe not. But it's also entirely preventable. Like, we only have to spend a bunch of money to fix it, and we already do that for so many crucial things. As for Richard Carrington, when he was made aware of the geomagnetic storm that happened some 14 hours after his first observation of the solar flare, he immediately made the connection. He thought that maybe the sun could actually influence the Earth's magnetic field. But he could never truly believe it. As he put it, one swallow does not make summer. And so he spent the rest of his soon-to-be tragically short life with an hypothesis that we could only fully confirm in the 1970s, when we finally discovered about the existence of CMEs. But going back to Richard, in 1865 his health had severely worsened due to some unspecified illness I couldn't find anything about. But he didn't let that stop him. 4 years later, in 1869, he married and he sold the family brewery for a pretty big fortune that allowed him to retire in a location not too far from his first observatory. And there he wanted to build a new one with better equipment, which would allow him to run cooler, bigger experiments. But sadly, life disagreed with him. In 1875, before he could conclude any meaningful work, his wife passed away, likely from an accidental overdose of a popular sedative of the time. I think it's called Coral, I'm not sure. Richard was devastated by this loss, and he was found dead in his sleep a mere 10 days after the fact. An autopsy later deemed it a death of natural causes, but we'll never know for sure. It's likely that Carrington went most of his life believing that his catalog of the night stars would be his most memorable and grandiose achievement, which is weirdly inspiring to me. You might live your life believing that you're fully aware of the impact that your actions have on other people's lives, when in reality you might matter a lot more than you could possibly ever realize. And if we really need to have another moral, is that you might experience a Carrington class event in your life, and you might want to keep that in mind the next time you're voting for your representatives in whatever country it is that you live. Just, you might want to make sure that maybe they're at least remotely aware of this possibility. It ain't gonna happen though. Thank you for watching. Please like, comment, and subscribe, and hype the video. I know it sounds like bullshit, but it genuinely helps as much as if I was paying to push the video to more people, and I don't want to do that because that's weird. Thank you for watching though. I'll try not to take another month and a half for the next video.